Alright, silly people, here's the situation. We have this matrix M1011, and we're just going to uh, figure out what the eigenvalues and eigenvectors are for it, as well as figure out if it can actually be diagonalized properly. The process for finding eigenvalues is that you take the determinant of the matrix multiplied by lambda times the identity matrix and set it equal to 0. So it's the determinant of 1, 0, 1, 1 minus lambda 0, 0 lambda that we set equal to 0. So it's the determinant of just 1 minus lambda here, and then 0, and then 1, and then 1 minus lambda here. And that determinant is actually just 1 minus lambda squared equals 0. We can take the square root of both sides, you get 1 minus lambda equals 0. So lambda only has one solution. There's only one eigenvalue for this. It's 1. So if there's only one eigenvalue, that means there's only going to be one eigenvector. So the process for finding that vector is we'll take the matrix M, multiply it by an arbitrary vector v, and then on the other side it'll be lambda times the vector v. So we've got 1, 0, 1, 1 times vx vy equals vx vy on the right hand side. Doing the matrix multiplication, we have vx plus vy and then vy here, and then compare that to the right hand side and see that if you go component by component, the only value of vy which satisfies this equation here is that vy equals 0, right? But then we can set vx to whatever we want. So we can set vx to 1, and we see that the normalized eigenvalue or eigenvector is just 1, 0. Kind of crazy stuff. So can it be diagonalized? The short answer is no, because if you did diagonalize it, you would have the matrix in some basis f would be 1, 0, 0, 1, which is the identity matrix. And that's a problem right off the bat, and we can prove why that's a problem, because if we do try and do a similarity transformation on M, then on the left-hand side we would have the identity matrix for the final result. But on the right-hand side we have the similarity transformation of M. What we can do here is we can multiply both sides coming from the left with an s to the minus 1. So we have s to the minus 1 times the identity matrix equals s to the minus 1 times s, m s to the minus 1. Of course, any matrix times the identity matrix is itself, and inverse times itself is just the identity matrix. So now on the right hand side we have ms minus 1. And then we can now multiply both sides on the right hand with a s. So on the right hand side we get ms minus 1 times s. Now the inverses cancel out again, so we get that the identity matrix would be equal to m. That's not the case, because we know that m is actually just 1, 0, 1, 1. So not equal to the identity matrix. So in doing all of that, we found a contradiction. So yeah, definitely not.